generations I made W25.
Sword and Shield?
It's oiled. They had the oil so much more fun.
I don't charge it.
They had Sword and Shield oil. That is the Sword and Shield.
Huh? Did you play it?
Yeah, but I remember it.
How do you remember it?
I played it before I left out. Like, I remember going down to like blog websites and repost Flash games.
Yeah.
Was that you?
Wait, where did you find Rad Road Racer?
It would be on like old, like Unblock 66 websites.
Oh, yeah.
Like, you go on like school websites and they just post a bunch of Flash games. Was that you?
That game sucks. Rad Road Racer.
It sounds pretty familiar.
Where do you see it?
And like I would just like go on the school library.
Yeah, what brought your mind to it? Why do you think I made it?
I found your name.
Oh,
Yeah.
yeah. Well, that's one I made. Yeah. It's one of my worst games I ever made.
I remember like you were like whatever.
Yeah.
Went down to the site.
Yeah. What a cluster Rad Road Racer was. It's literally just like pothole dodging the game.
Yeah.
Except the potholes are way too fast and your car's too slow. And you can get to the point where like there's a car you have to get past. And it's hogging one lane of the two lanes. And so you go to the other lane and then you get slapped. You get slapped down by a pothole. Right? Like it was yeah, and there's nothing you could have done right there. Absolutely nothing. Right? What a piece of garbage. But because of the aesthetics, a lot of people played it.
Yeah.
And there's nothing rad about that game. Anyway, yeah. Yeah, let's keep this to ourselves, huh? Okay.
There's no way to find it.
Really? You can't play it?
Flash is down.
You can still play Flash games.
Not the browser.
My browser still can. Okay. All right. Okay. Ladies and gentlemen, everyone, welcome to another week of EECS 498 Game Engine Architecture. Congratulations on finishing what I think most people last year said was the hardest assignment in the entire course. Homework 6, devilish homework 6, okay? And you made it through, okay? Now, you may not have gotten 100%. Maybe you didn't get all of the performance and integration test cases. And you should know that that's totally fine, okay? It's not going to be a huge deal, all right? So long as you got a nice chunk of the points on homework 6, you're going to be set up very, very well. And if you didn't get a huge chunk of the homework 6 points, that's okay, because homework 7 rips out most of the logic from homework 6. So homework 7 is a good reset point for you, okay? And so if homework 6 was a nightmare, with homework 7, you're going to be back in the game.
I was just going to ask how much a good chunk was, but then you're like, oh, it's going to rip out most of the 6's logic. So I figured like anything that's not exactly the integration test cases would be fine.
Like, all your collision logic is gone now.
Yeah.
A lot of your gameplay logic is gone. Your input logic, some of it's gone. If you made an input manager, you'll reuse that part. A lot of stuff's gone. Your rendering tech is still there, but anything specific to the gameplay is gone. So, yeah, I think hopefully you'll find this to be cathartic to kind of rip out that code, and some of the bugs that might be hiding in there are going to go out with it, okay? Yeah, I hope you'll enjoy homework 7. Homework 7 is the name of the game now, okay? And we're going to be spending most of today talking about homework 7, and in particular, talking about Lua, okay? If you're currently working with each other, if you're currently working in the lab, right, please whispers only from here on out. Thanks. Yeah, here we are. We are at the beginning of a very long assignment, language hosting, number 7. And it is long in part because you have 3 weeks, 2 of them dedicated to the assignment itself, and 1 in the middle for spring break. Now, hopefully you won't spend any time using that spring break week for your assignment. Our goal is that, hey, you can just work this week and then work in that final week when you come back, and you're going to be golden, Okay, that's what the assignment is designed to do, and we're pretty sure you can make that work. But for those of you who feel really behind or just want your board or something on spring break, it's available. Okay, you can do what you have to do. Okay, first though, I have a engine of the day for you that is very near and dear to my heart. This is Adobe Flash. You mention Adobe Flash in many game design circles, and you'll see eyes light up, and then their hearts will break in front of you as they bemoan the loss of Flash. Because it has been about a decade since Flash has been impactful and prominent, and still nothing replaces it. The closest I've seen is UbiArt, which we saw last time, and it is not open source. It's not available publicly. You have to go work for Ubisoft if you want to use that engine, and working for Ubisoft might be really tricky for everyone soon, okay? So anyway, this is a 1996 piece of technology. It was initially created by a company called Macromedia Flash. And Adobe acquired it in 2005. Adobe is the kind of company to take a good thing and kind of crush it and leave it to die and rot. And that's exactly what they did with Flash. It's very, very sad. Before I show you what Flash was like to use and talk about Flash's demise, which is one of the more interesting aspects of the engine, I want to show you what Adobe Flash created, okay? In the era before YouTube was really blowing up, okay, in the era before itch.io, before Steam, if you wanted to play a unique indie game, there's a very good chance you'd be told to go make it in Flash. Why? Because Flash, via the Flash Player plugin, was the multimedia engine of the internet in the early 2000s to mid 2000s. Okay? If you want to play a game in your web browser, you had to have Flash. Okay? If you want to watch a film or a cartoon, you do it in Flash. And Flash was so good at allowing for quick animations and adding logic to those animations, i.e. games, that so many people got their animating and game dev start in Adobe Flash. Okay? Websites like Newgrounds, which are super powerful and popular today, okay? Armor Games, XGen, Albino Black Sheep, which was a huge one back in the day. This is what you did in middle school and high school, right? When you wanted to go play games in the computer lab, you couldn't download anything because you couldn't install anything, but you could usually find a site that would let you play some Flash games, okay? How many of you played Flash games? I'm losing track of how old I am. Eventually, the number of hands up will go to 0. But just to remind you of a couple things, right? The Evil Strawberry, archived on YouTube.
You want the strawberry? You can't have it.
I want to have it.
You're a stupid little baby, man.
I want to do it.
You're stupid.
Yes, Mom.
The subtitle.
Oh my god.
Okay, so, right, that's the kind of thing, right, that someone would make up in a few weeks, animate, voice act, and then it would go viral on the internet, right? Suddenly everyone in the computer lab would be watching it and having a very good time sending that kind of stuff to each other. Lots of stuff like that. I'm going to show you one of the most treasured animations from that era. We're going to watch the whole thing. There are a lot of these that are classics, but I think this is the one I had to show with the amount of time we have.
Godzilla was hopping around Tokyo City like a big playground when suddenly Batman burst from the shade and hit Godzilla with a bat grenade. Godzilla got pissed and began to attack. AK-47 out from under his hat, flew Batman away with a rat-a-tat-tat, but he ran out of bullets and he ran away because Optimus Prime came to save the day. This is the ultimate showdown of ultimate destiny. Good guys, bad guys, and explosions. As far as the eye can see, and only one will survive. I wonder who it will be. This is the ultimate showdown of ultimate destiny. Godzilla took a bite out of Optimus Prime like a gun took a bite out of crime, and then Shaq came back covered in a tire track. But Jack Chan jumped out and landed on his back, and Batman was injured and trying to get steady when Abraham Lincoln came back with a machete. But suddenly something caught his leg and he tripped, and Indiana Jones took him out with his whip. Then he saw Godzilla sneaking up from behind, and he reached for his gun, which he just couldn't find, cause Batman stole it and shot and he missed. And Jack Chan deflected it with his fist, and he jumped in the air and he did a somersault. But Abraham Lincoln tried to pull a fault onto Optimus Prime, but they landed in the air, and they both got hit by a Care Bear stare. This is the ultimate showdown of ultimate destiny. Good guys, bad guys, and explosions. As far as the eye can see, and only one will survive. I wonder who it will be. This is the ultimate showdown. Angels sang out in an immaculate chorus. Down from the heavens descended Chuck Norris, who delivered a kick which could shatter bones into the crotch of Indiana Jones, who fell over on the ground, writhing in pain, as Batman changed back into Bruce Wayne. But Chuck saw through his clever disguise, and he crushed Batman's head in between his thighs. Then Gandalf the Grey and Gandalf the White and Monty Python and the Holy Grail's Black Knight and Benito Mussolini and the Blue Meanie and Cowboy Curtis and John B. the Genie, Robocop, Terminator, Captain Kirk, and Darth Vader, No Pants, Superman, every single Power Ranger, Bill S. Preston and Theodore Logan, Spock, the Rock, Doc Ock, and Hulk Hogan all came out of nowhere, lightning fast, and they kicked Chuck Norris in his cowboy ass. It was the bloodiest battle that the world ever saw, with civilians looking on a total loss. The fight raged on for a century, many lives are claimed, but eventually the champion stood. The rest saw better, Mr. Rogers' blood-stained sweater. This is the ultimate showdown of ultimate destiny. Good guys, bad guys, and explosions. As far as the eye can see, and only one will survive. I wonder who it will be. This is the ultimate showdown. This is the ultimate showdown. This is the ultimate showdown of ultimate destiny.
Okay, right. So you can get a sense of kind of what the culture was like in that era, in that a lot of the things made in Flash were kind of edgy, right? They were very, very tied to popular culture. And another thing I want to point out here, watch this intro really quickly, right? You can see here a good example of vector animation. So Adobe Flash is a vector authoring tool. It's a vector-based engine. It doesn't really use bitmaps a lot. And so you can actually take this right here. It's the kind of thing you would make in Adobe Illustrator, where you can zoom this as much as you possibly want, and it has perfect resolution, okay? It is not a bunch of bitmaps, a 2D grid of RGB values. It is a bunch of math expressions, okay, that allow you to create really smooth art that can zoom and scale infinitely and still look pretty good. And it was just really, really nice. It was super easy to create keyframe animation. It was super easy to do stretching and zooming and all sorts of stuff and have it automatically interpolate. It was too beautiful for this world, okay? Anyway, really, really fantastic stuff. And you could find all of these online and easily consume them. You could do it in schools, okay? Imagine like showing stuff like that to your friend in school. You're automatically the coolest kid in the room when you do that, okay? That edge, get in there, right? Anyway, it was very kind of unceremoniously crushed by Apple. Steve Jobs took it out behind the shed and said, enough, Flash is dead. Basically what happened, Adobe, officially, according to Steve Jobs and Apple, Adobe was not able to ever get Flash Player to be secure enough and performant enough to be worthwhile on Apple's new smartphone device called the iPhone. Okay? The iPhone became really big, and the iPhone declared that it would never support Adobe Flash. Okay? It was going to basically put all of its might behind HTML5 as a kind of internet-based technology, multimedia technology instead. Not a bad idea. Jobs wrote a famous letter, Thoughts on Flash, in 2010 that basically explained why Flash is not going to be available on iOS devices. It's all well and good, but as you read the letter, please keep in mind that Apple has an app store. Apple has a bunch of APIs that severely restrict what you can do on their platform. And you know what kind of ruins all of that? If you can just open your browser and do things in Adobe Flash, right? So Steve Jobs and Apple do have a strong incentive to put Flash out of its misery as well around this era. Flash would be retired and moved to a software called Adobe Animate, which as far as I can tell does not get a whole lot of love, has not been updated all that much, but it still kind of sort of has Flash's features. And you can still kind of make it work there if you want to, but it lost most of its mojo. So as far as the development experience goes, Flash ran via a plugin. Okay, you would go to a website and there would be a little Flash embedded object in it, and if you had the plugin, it would just load. It would run just fine. Awesome. If you didn't have it, you'd have to click on some things. You'd have to download and install a plugin, and then it would suddenly work. Okay. That Adobe Flash plugin was constantly being updated. It was very annoying to do so, and it was constantly resulting in security hacks as well. Okay, so it was a very big vector for people going to a website and getting hacked, which still happens these days, but not nearly to the same extent as far as I can tell. HTML5 and Canvas didn't exist yet. So if we want to make a game like what you see at the top of EECS498.com, if you want to make a game like this, you couldn't. You simply couldn't. Okay, you had to use Flash, pretty much. All right. Okay. Wait, did I just go to EECS498.com and the 298 stuff spawned? No. Okay. Good. All right. The scripting language here was called ActionScript, and it was kind of a variant of JavaScript. There's an example here. Okay. Right? So you've got some function declarations. You've got some variables up here, right? Blah, 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 blah. You can do event-based programming, so add listener, right? Run load file, okay? Blah, 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 blah. Note how it's associated with a particular frame. Each frame of an animation could have custom logic. So you could have, for instance, at frame 5,532, you could have a certain sound effect play, right? Or a certain character come in, or even a mini game start in the middle of your film. It was super, super flexible and super cool. It was very integrated with vector art animation coding tools. Some example footage. Yeah. Right, so you could get in there, you would create basically a scene, a movie clip it was called. You would get a timeline, which everyone who's used to Blender is very used to seeing this. Right, you could easily draw here. You could draw really beautiful kind of vector art very quickly, okay? Then after drawing it, you could go in and manipulate it really easily. So you could reshape it, you could alter it, give it a new kind of style, right? Shade it. And all of this was just very, very, very nice. You could then go animate it, right? And I think this is a 10-minute video in which the character shows you how to animate and create keyframes and have the character kind of interpolate their position and their rotation, but also change their sprite, okay? It's just super, super, super cool. My goodness. You could then export it as a .swf file, and then you could watch it. So yeah, here's the final clip, right? And you just watch it online on Newgrounds or something like that. And hello, come on. Yep, there it goes. Squash and stretch, super easy. Looked amazing. I'm getting sad just thinking about it. Okay, this Flash actually still lives on today in the form of Scaleform, which is a tool that Autodesk used to support that basically allowed you to convert Adobe Flash animations and movies and games into UI for AAA C++ powered engines. As far as I understand, Jackbox Games, where a bunch of my students work, like the Quiplash minigames, the Party Pack stuff, those are all Adobe Flash games. Like if you go to work at Jackbox, you're going to be writing Adobe Flash code, which is awesome. Okay, maybe I should go work there. I don't know. Those games are too social for me, I think. Anyway, super, super cool. I hope you will go learn more about Flash and maybe even see if you can check out Adobe Animate, all right? And maybe you'll feel the magic as I did so long ago. It was basically my second ever game engine. First was GameMaker. When I got really serious, I got $250 somehow, and I paid for Flash, and it was awesome. I got a bunch of games scattered out there on the internet, and I'll tell you about exactly none of them because they were all terrible, okay? All absolutely awful. Okay, some of them were popular, and that was sad. All right, so homework 6, how did it go? This is a very different homework 6 than what you got last year. Last year, hardest assignment, probably the worst and nastiest assignment in the entire course last year. This year, we got a bunch of people with hundreds and a bunch of people with like 90 plus percents. How'd it go? I'm going to get your feedback via the feedback forums, but
I tried implementing collision detections in like 4 different ways. I implemented every single optimization on the homework list except for text caching, but I was still 200 to 300% over on most cases.
Interesting.
So I think I just had some memory overhead thing wrong in some place that I couldn't get down.
That's the really hard thing about optimization. Like tiny things can really get you. Like the profiler is, you kind of live and die by the profiler.
So I used the profiler, and it was like, oh, you're doing, you're making a bunch of extra, vectors for like sorting. Like I would do a move, and I would like categorize like old regions and new regions, and I like before like setting up a vector, I did like a Boolean check to see if I needed to. Yeah. And it was like, when you're making the vector, that's all your thing. So I was like, okay, I cut that out, and I redid it, like meant to manually do things one by one. And then I submitted that to the auto grader after doing a performance profiler. It went from like 60% of my code to like 4% of my code. Okay. Submit that to the auto grader, and I was like 4 times slower on everything. I was like, all right.
Did it improve?
No, it was worse.
It got 4 times slow.
Oh, it got 4 times worse.
Yeah.
Yeah, that's happened to me a few times. So optimization, right? It's the profiler, yes, but it's also experimentation. Just because something runs faster now on your machine won't necessarily mean it runs faster on other machines. That's how it is. One of the really powerful things about making games for a console, like if you are a first-party Sony developer, if you're Sucker Punch and you know exactly what hardware and what software, what software stack, what operating system you're going to be making your game for, that makes profiling, makes making the software much easier. Okay, because now you're just dealing with the PlayStation 4. And for the most part, every PlayStation 4 is the same. Okay, so that definitely helps. Okay, anyone else? Yes?
It's very frustrating to get my code like optimized on one platform and then it'd be much slower on the other.
Yeah, that's how it goes. Yep. The impression I get, a few of the tips we left on the homework 6 assignment spec were kind of general tips. Like in general, we don't render things that we don't need to render. We don't update things. Well, we don't sort things that don't need to be sorted. And there are certain things you can do, like without going any more specific than that, I think there are certain things you can do that a lot of students aren't doing that are kind of hurting them. Because I went through, and we aren't doing a bunch of really crazy stuff in the staff source code. Like, I was actually surprised how few optimizations we're actually doing. But in any case, it's okay, right? You don't need to get all those points. This course doesn't expect you to. There's a lot of extra credit coming as well. And so as much time as you have, you put that into optimizing, you'll learn some things, but you don't need to, okay? So don't feel too bad if you didn't get every last point, okay? In 494, right, I can... Basically, we're okay with any grade outcome, any average grade. but it is on me in EECS 498 to ensure that we have like a B plus average tops. Okay, so we have to make some very hard assignments in this course. That's simply how it is. Okay, so homework 9, data-oriented design, is under development now. It looks like it's going to be one of the easier assignments, how it's shaping up, especially if you keep up with homework 7 and homework 8. If you keep up and get most of the points on 7 and 8, I think you're just going to steamroll homework 9, okay? So make of that what you may, do what you can. A Hacker News discussion on the need to make games while making a game engine. I think I saw this last year, and I thought it was kind of cool. Right? And immediately we get someone stating, I like how the Blender Foundation creates Blender movies with the intention to improve their tool by using it in a production, realistic, kind of commercial environment, right? As you are working on an engine, if you continue to use your engine and build upon it after the course ends, make games, right? Take your engine and see what you can make with it. Can you make a quick little game in a couple hours, right? The chances are probably yes. I think next time on Wednesday, we're actually going to make a game together. Or maybe when we come back from break, we're going to make a game together. We're going to spend the full hour and we're going to build a game so I can give you a feel for how your engine really works for an end user. Hopefully that will also help you understand why what you're doing on homework 7 is so important, okay? Why every function really matters. So with that said, we should talk about homework 7, okay? Let's get to it. This is my favorite homework in the entire course, and I'm sure that there are going to be some things that are rough about it that I'll fix. I really think you're going to like this one, especially if you can get started on it a little bit early, especially if you can kind of grok and understand what components are and how can we start to create them out of tables within Lua, okay? All right. So homework 7, okay? This homework is all about externalizing the final thing we need to externalize to truly move away from a moddable game to a fully fledged engine, okay? Thus far, we've been able to customize everything in our engine except the rules, okay? But now the rules, too, will be customizable. We're going from a top-down adventure game engine to a Qt-em-up, possibly, okay? Different genres require different logic, and whereas this is all hard-coded in C++, right? Nasty hard-coded code. Over here, we're going to use Lua to basically put it on our users. Our users will decide what the rules are. Our users will decide what the algorithms are, how fast the collision detection is, okay? This week, it's about a new language, and it's about a new architecture in your game engine. This is a 2-week assignment, and you should really give that respect, okay? This is not a trivial assignment. This is not an easy assignment. It's probably not as hard as homework 6, but there's a lot to do, and I think you're really going to like it. Architectural changes. You've already kind of seen this, but I'm going to keep hammering it home. In the past, you would have one actor, and that actor would have a ton of random properties, variables, right? Floats, bools in here. And every float and every bool and every variable, it only mattered because you wrote C++ to make that variable do something or turn something on or off. But in a world where we don't know what genre our user is going to want, like we can't possibly write enough variables. We can't hard code everything, okay? And so we have to give that power to our users, okay? This is level 1.scene. You're looking at one actor named Donna in that scene, okay? Donna has a bunch of components, 5 of them in particular, and each component has a component type, along with some variables that go with it. Each of these types will map to a Lua script, right? SpriteRender.lua, KeyboardControl.lua, Donna.lua, DonnaAnimation.lua, and each of these Lua files will define a table that defines a Lua type, okay? Let's go ahead and open this one up in particular. This is keyboard controls, and it has one variable override called speed, okay? And it's getting the value 6. When you look inside of keyboard control, you will find what's called a Lua table, okay? A Lua table named keyboard control that has 3 things in it. Can you tell me what the 3 things are? This looks like a lot more than 3 things. But part of getting better at Lua is realizing that Lua tables are just key value stores. And Lua is just JSON. Okay? It's just JSON. It's the same thing.
It has a speed, it has an on start, and it has an on update.
Bingo. This Lua table has 3 items in it within it, 3 key values. Okay? Speed, on start, which is a function, and on update. Okay? After each key value pair, you get a comma to delimit them. Okay? So there you go, right? It does really feel like Java or JSON upgraded to be able to store things like functions and numbers and stuff like that. Okay? These speed values, okay? This speed variable in particular, by default, it is 3. But in this case, this particular component on this particular actor, the speed will not be 3, instead it will be 6, okay? And so components, right? The rival to inheritance, which we talked about at length a few lectures ago, is how we're going to reuse our logic, okay? So one cool thing, especially if you're used to Unity or Unreal Engine, okay, all those 494 and 440 students in here, okay, this right here, these are basically equivalent components. And the syntax is a bit different, right? But look at it. You've got your public variables toward the top, okay? And they can be edited, they can be overridden, they can be altered from the inspector, okay, to be different from their defaults. You have a lifecycle function, start, okay? This will run automatically when the component gets added onto the actor, when that actor spawns in, often when the game starts, okay? And a bunch of actors are loaded, and all their components are loaded, okay? You've got this lifecycle function, update. In our engine, it's called onUpdate, okay? This runs every single frame, no matter what. Well, if our component is enabled. You've got things like conditional logic, okay? You've got if statements. You've got APIs, input.getKey, input.getKey, okay? And at the bottom, right, you can see that we've got the keyboard control actually moving our object. How does it move our object? It does so by grabbing another component. We got the keyboard control component, which grabs and uses the transform component on the same actor in order to move that actor. Same exact things happening. After homework 7, you should be entirely convinced that, oh shoot, I actually have a little mini Unity now. Okay, after homework 7, after you complete it with flying colors, you should say to yourself, dang, I could probably work at Unity, and you could probably be right, okay? Right? Like the steps you're taking are the steps that people walked when they were creating Unity, okay? And that's pretty darn cool, I think. So some quick tips. Lua, and we're going to talk a ton about Lua in just a moment, but Lua is much easier to understand and visually parse when you realize that it's all just a JSON blob, okay? Key value stores are everywhere in Lua. You're used to JSON blobs that look like this. On the left, you've got keys. On the right, you've got values, okay? And the delimiters here are a colon and a comma. The colon separates the keys from the values, and a pair, a key value pair, are delimited from each other via the commas, okay? And so, look at this component right here, this Lua script. You have what? Keys, right? Speed, on start, and on update. You have values, okay? The 3, this function and its body, and this function and its body. And the delimiters are just slightly different, okay? Instead of being delimited by colon and comma, you are delimited by the equal sign and the comma, okay? And so, there you go, all right? It's JSON all the way down in this course, all right? So some tips for you on this assignment. Yes, question?
Does the name at the top have to match the name of the file?
Yes, yeah. In our engine, it does. You can change that if you want to when when the summer begins and it's just your engine. But for us, yes, it's assumed that this is true. Okay. Anyone else? So some tips on this assignment, okay? Try and keep a consistent pace. This is one of the longer assignments. And this isn't a super hard milestone, okay? But it can be made extremely hard if you wait too long, okay? Jamming all of this into the final week, not ideal. Jamming all of this into the final 3 days, final weekend, complete catastrophe, okay? It's going to be a nightmare, all right? This should be a tough but satisfying assignment. And one of the reasons it's going to be tough is you're going to need some time to kind of fully understand what's happening in Lua. It took me, people say Lua is a very simple language, and it is, but its simplicity kind of adds a big mental load as you're first learning it. Because Lua does so much with so little that the way it does it all is very unlike other languages, and it's very dense. It's a very small but very dense language, okay? So this is an assignment that requires you to add a ton of features. Luckily, most of them just aren't that hard to add once you understand what's going on. Some are quite easy, and a couple, especially the early ones, just getting everything going at the start requires some thought. 2 weeks might give you a false sense of comfort, and I would say especially that we have 3 weeks. It's a very dangerous thought to think you can just put a lot of this off. But I think this is the coolest assignment. Maybe you'll prefer the physics assignment, homework 8, or the particle system assignment, homework 9. But I like this one the best. And when you complete it, you'll be shocked how powerful your engine is, okay? This engine you're making is going to start to very significantly resemble a hybrid between Love 2D, which is our Lua-based minimalist engine that you did in the first 2 weeks, and Unity, okay, which is the big, heavy, famous integrated engine that you might have done in the first 2 weeks as well, and that you will do if you take 494 or 440, okay? Off by 1 pixel errors, I regret to inform you, they've been canceled, okay? Why have they been canceled? Can anyone tell me why?
Moving away from ourselves placing the objects and you're not placing the objects.
Yeah, right? So all of the calculations that decide where something will be drawn, where will it be, most of those calculations are now in my control because I'm the one that writes the test case. Your engine runs my Lua code, which runs the test case, okay? And thus, you'll all have the same logic in the test cases at least. So this makes off by 1 pixel errors less likely. They can still happen, but much, much less likely. And similarity scores will probably help you out there. Yeah?
Will you write Lua code?
On this assignment?
Yeah.
Nope. But you will need to understand the test cases, okay? And you will need to write Lua code on the exam. And you'll have to understand Lua for homework 8 and homework 9 as well. So it's definitely the case that you're not going to want to sleep on Lua, okay? Right? It might be possible to get through this assignment without having much of an understanding of the language, but it's going to be very unpleasant and it won't be as satisfying either. Yes?
What is the thing with the red face?
Malin McGeary, who created these characters, told me that is a pizza.
Huh.
Yeah.
I kind of see.
I see pizza. I don't see what the red thing is.
Yeah, it looks like a wrapped. It looks like a wrapped pizza to me, like a cone pizza or something.
Maybe. It looks like a weird 3D-esque pepperoni.
A weird pepperoni. Yeah, I think it looks delicious. Like I would definitely eat it. It looks delicious. Isn't it like a calzone or something? Isn't that like a pocket pizza or something?
Yeah.
Something like that.
Yeah. Yeah, well, in any case, this game was themed around salty characters versus sweet characters, right? So salt versus sugar, and so that's basically Malin was just coming up with salty snacks and foods and stuff like that. So anyway, that's it. That's all I've got for homework 7. What I want to do is I want to actually show you the assignment spec because I think I need to intimidate all of you into starting this one early. And so I'm going to try and do that right now, actually. What's up?
All you need to do is tell them how many submits that I made on the
Yeah, how many? You can tell them. Do you remember?
Probably like
Yeah.
6.
Someone just said Joe. I don't. Why? Who's saying Joe? Okay. All right. So you may think to yourself, hey, this is cool footage of your game engine from week 1 and 2, but there's this little spoiler for you. I'm not going to spoil it for you, but this is not the engine from week 1 or 2. What's up?
The TV's supposed to turn on.
Oh, no. Is that why everyone's hands are up? I thought you all had good questions all of a sudden. Okay. Is that it? Any other questions? No? Bummer. Okay. I'm so excited. Flash like Homestuck. Was Homestuck Flash?
Yes.
Oh, interesting. Okay. Did Toby Fox know Flash? Did he do Flash back in the day? He was on Homestuck, I think.
He
just
did
did music
Hussey.
for it.
Just
I
did
know
music?
someone who knows both Toby Fox and Hussey. I will ask her.
Okay, cool. Tell him to come do a guest lecture or something. That'd be cool. Yeah.
It's not that far.
It's not far. You know where he lives? Oh, goodness. Oh, goodness. Okay. All right. So, everyone, this is homework 7, language hosting. Okay? There are 16 pages in this assignment. And it just goes on forever. There are dependencies, new dependencies. You've been spoiled. Homework 6 didn't require you to integrate anything. Okay? I will say, I think very few people had as much problems with Lua integration as they did with SDL. But it's still not a small thing, okay? There is a demonstration video to help you, but only for Windows, it looks like. Sorry, everyone. Yeah, I guess it's easy to port it. Otherwise, I would have done it for the other languages. If you complain to me hard enough, I'll do some recordings for the other ones. Yes.
Oh,
Yeah, that's fake. I can tell it. I can hear it in your voice. Okay. So you've got a couple task suites that are just refactoring your engine code base with some advice. You've got component loading, getting OnStart to run, getting the debug.log functions to print things to the console, okay? You're going to have to do a lot of work here, okay? This is a multi-page test suite 0, okay? Setting the tone right away. Okay, you've got inheritance and overrides, and you've got actor templates. So if actor templates are something that have caused you a lot of heartburn in the past, this is a big one. Templates are a huge source of bugs on homework 7, okay? Once you get them working, they're very, very nice, though. Referencing, so being able to grab one component from another component. That is not something that is built into Lua, okay? That's something you have to make work, all right? Have any of you used Unity? How many of you have used Unity? You remember the function GameObject.find and how nice it is? You just provide the name of the object and it just grabs you the object. You can then grab any component you want.
We're going to have to write that?
Yeah, except you're writing, let's see. Hold on, right here. Let me just zoom in for you.
Oh no!
Oh no!
Oh
Yeah.
Oh no!
This shouldn't be a surprise, but you're implementing a lot of the Unity API when it comes to game objects, okay? You're going to implement don't destroy on load. You're going to implement get component. You're going to implement destroy on a component. You're going to implement all sorts of stuff. You're going to implement add component to add components at runtime. You're going to implement actor.spawn. Okay, instantiate, it's actor.instantiate instead of gameObject.instantiate, okay? And so look forward to all of this. It's actually not so bad once you get going. You're going to be making sure that if there's an error in the Lua code that your game designer wrote, that your engine doesn't crash, and that you output the appropriate error message so that your game designer knows where the error occurred and what line of code they should go fix.
Are we allowed to use try-catch?
Yes.
Okay, that makes sense.
Yep, that's how you'll do it. You will write classic functions like application.quit. That's not a very hard one, okay? Application.getFrame, application.openURL. That's a sick one, okay? From Unity, all right? You'll write input.getkey, input.getkey down, getkey up, mouse button stuff, get mouse position, okay? You're going to do the .enabled property that all components have in Unity. You're going to make that work. Actor.add component, okay? You're going to make that work. Remove component, instantiate, destroy, okay? Text. You're going to do some UI stuff. Audio.play, halt, set volume. Image API, image.draw, image.draw UI, draw UI X, okay? Oh my goodness. You're going to have a camera API for moving the camera around. Camera.set position, camera.set zoom. I heard that many of you already have camera stuff, okay? So understand that a lot of this sounds like a lot, but you'll be surprised how easy a lot of it is because you already have the tech for rendering. You already have the tech for moving a camera around. You just kind of link stuff up. If this Lua function makes this call, I make this C++ call to carry that out. What is that? 2 minutes? Boom, done, next, okay? You'll discover that while we have a ton of test suites in here, some of these test suites are gonna go down in about 30 minutes, okay? First try. So don't be intimidated, but also don't start too late, okay? Really do get into this. I'll say as soon as you get rolling, these test cases all get knocked down easily for the most part. But you really, these first few test suites are a doozy, okay? And but that's where you build the core of your component architecture. On Wednesday, I'm going to help you plan out your component architecture and how you should think about it and how you can start really going. It's not all that bad once you get your data structures right and once you understand a little bit of Lua and a little bit of Lua Bridge. The assignment, by the way, is going to help you with all of this. There's a reason that test suite 0, the amount of text in here, is like 2 pages. It's because we're giving you tips on what things you might want to think about and use. All right? So, yeah, be a little bit intimidated, but not too much. All right? One thing that kind of happens to me is when I am nervous about something, I put it off. And that's the worst thing you can do. All right? So if you're nervous about something, you always want to attack it as soon as possible so you can get a feel for how difficult is this really going to be. Okay? That allows you to make vastly better scheduling and time allocation decisions with all your other courses, your other assignments, stuff like that. Okay? So, all right, what else do we have going on here? All right, homework 7. Okay, Lua and scripting. Let's get into it. I want to script some Lua with you. We got 45 minutes left. All right? Oops, that's the end of the whole thing. Let's see here. Okay, so let's talk about Lua. I love talking about Lua. It is such a strange little language. Okay, Lua and scripting. Okay, it was a language created in 1993. That was a year after I was born. It was created, and this is one of the coolest things in my opinion. It was created at, oh gosh, I can't remember the exact full name. What was it? Okay, Pontifical Catholic University of Rio de Janeiro. Okay, so this is a Brazilian invention, which is super cool. And it was created to be extremely small. Okay, Lua is a dinky language. All right, it is 150 kilobytes in its runtime. And for what it's worth, this image right here is 50 kilobytes. So if your hardware can store 3 of these images, then it can run the Lua runtime. Yes?
What does 150 kilobytes runtime mean?
What do you mean? Oh, like the amount of RAM it needs.
Okay.
Yeah. Like if you have less memory than this on your Nintendo DS device, you can't have Lua. But if your mobile phone has 200 kilobytes of RAM, then it can probably run Lua. Okay? So it's a very simple language with a big asterisk I should put on that. It has 21 keywords, okay? And it does a lot of things. It only has one major data structure, okay? Which is the table, the famous table. Oh, goodness. All right? Those things are a doozy, okay? It is somewhat popular, okay? We are not wasting our time by learning Lua in this course, not by a long shot, okay? There are a lot of tools that embed Lua, like Roblox Studio. Have any of you heard of a tool called Wireshark? if you've taken the security course, EECS 388, you will have heard of it. It's a great tool that allows you to basically sniff and analyze packets as they travel through a network or even over Wi-Fi. You write your plugin for Wireshark in Lua. Okay, it just keeps popping up everywhere. Okay, Roblox Studio, the default game engine, uses it. Okay, a lot of game engines out there use Lua. The Halo Infinite engine uses Lua. Okay, I don't even know if I should mention that. Is that a feather in the cap or not? But a lot of engines use Lua. Okay, it has, however, become overshadowed by other scripting languages such as C#, which Unity. Okay, Python. Okay, Pygame. Right, JavaScript even. Right. So a question then is, why choose Lua? Why did we choose Lua? Well, for a couple of reasons, but
Easy to integrate.
Yeah, easy to integrate. Absolutely. What else? It's easy to integrate, but it's fast. It's good, right? It is a respected language. It's also, and this is a fun, pragmatic thing, we're the only course that teaches it. Okay? JavaScript, 485. Okay? C#, 494 and 440. Python, I feel like a lot of courses teach or use Python, right? 183, I think, uses it a little bit.
Just at the very end, like a tacked up 2-week section.
Okay, 445, a machine learning course, when I took it, used Python. Okay.
497 uses it.
Okay.
390.
Can't you do whatever you want in 497?
Not when I took it.
Oh, interesting. Okay. So, that's like a logistical thing, right? We want to offer as many ways to learn these things as you can, so we'll use JavaScript, Lua. So it is popular. If you look at the TIOBE index, right? Python is number 1, C#, number 5, JavaScript number 6. I bet Lua is number 7, right? Well, 33 isn't horrible. Top 50 language, okay? It is right in there next to Scala and Objective-C, okay? Julia and Lisp, it's hanging out with the functional languages down there, okay? And Lua is a functional language, so that kind of makes sense. As far as scripting languages go, why would you choose something like Lua over a C# or a JavaScript or a Python, right? You can analyze them in many different dimensions, right? What uses these languages? Well, C# has Unity and Godot, right? Huge workhorse here. Like, sometimes I think that this is the thing that is keeping C# relevant. That's not the case, but sometimes it feels that way. JavaScript, right? Web dev. It is the language of client-side web dev and even server-side web dev if you're doing something like Node.js. It is also used by engines such as CopperCube, and a lot of web-first engines use JavaScript as their scripting language for that reason. Okay? With Python, you've got Pygame, right? You've got other engines like Sims 4 engine that uses it. And with Lua, we've got Roblox and Default Studio. So it's competitive, okay? The ecosystem is very strong for C#. You've got an enormous amount of cross-platform packages with NuGet and .NET. With JavaScript, you've got NPM and other stuff. With Python, you've got the Python standard library, which seems to have everything under the sun, okay? That thing is gigantic. Lua has the LuaRocks library, which I've never used. It doesn't seem nearly as big, but it is there, okay? The ecosystem is not as strong for Lua, okay? Performance, right? C#, it is fantastic. JavaScript, fantastic. Python, okay. And Lua, pretty good. Lua can be made much faster if you use a library called LuaJIT, and at which point it becomes maybe even faster than C# or JavaScript. But with our just, vanilla Lua interpreter that we're going to be using, it's fast enough, okay? Still pretty fast. The size, C# and JavaScript, right? Both pretty large. Python, medium-sized, about 6 megabytes, and Lua is dinky, okay? 150 kilobytes. If you are making a game for the Nintendo DS and you're really constrained, or if you're making it for the Game Boy Advance, okay, then you're going to want to use something small like Lua. As far as integration, this is the true victory for Lua. C#, JavaScript, Python, they are all embeddable, but the documentation isn't that great. Python in particular, I've heard that Python, by default, it really wants to assume that it's the only thing, right? It is like the center of the universe. Python is very needy, okay? Lua assumes that you're embedding it, okay? And it's just very nice for these reasons. Yes?
In general, with things like Python, you don't want to embed it. You want to also have a Python system, some Python code on your computer, and then you do interoperability.
Yeah.
Like, you write C functions, compile it, and then call the native C functions from Python.
Yep. So things are a little bit different, a little bit spooky. Minimalism, right? 2024, memory is not that valuable, okay? Unfortunate, but true. Actually, kind of fortunate. Features and dev time are what are super impactful in 2025, okay? It is sometimes said that as computer hardware gets faster, we don't really get faster programs. Why? Because our software gets worse at a faster rate than our hardware gets better, okay? As our hardware gets faster, as we get more RAM, as our CPUs and GPUs get faster, we write worse code, because what matters truly, dev time, is what people really care about these days, okay? That has not always been the case, okay? But as speedy development and features, getting the features out fast, have become more important, Lua's become less popular, okay? Games like Binding of Isaac, okay, right, on the DS, however, still have a use for Lua, because you do not have a lot of memory on these kind of tiny, cheap, consumer-grade embedded devices, okay? There, memory is once again at a premium. There, we go back in time, where Lua shines. The Playdate handheld device, anyone see this before? Wait, hold on a second. It lives. Does it have any battery, though? You know, it's the battery's toast. But if you want to check it out, you can. It's got a little crank. A little fishing mini games and stuff. It's kind of cool, right? Anyway, this is basically like a widescreen, 1-bit, no backlit Game Boy. All right, and these devices are surprisingly popular these days. And these are very cheap devices. Well, kind of, not really. They're very underpowered, okay? And so you need to be careful. Playdate, if you want to program a game for Playdate, you're writing all your logic in either C++ or in Lua, okay? And it's a lot of fun to do so. Playdate specs, right? If you are using an engine like Pico 8, right, it's going to force you back into a more minimalistic era. You're going to be writing Lua. You're going to be dealing with memory constraints and rendering space constraints, okay? Right? Minimalism and embeddability still does matter, all right? These are more niche use cases, but they're niches that people really love, all right? And so we can expect them to stick around and possibly even grow. In any case, Lua is the perfect scripting language for a time-strapped game engines course, where I'm guessing you spent enough time trying to integrate SDL into 3 different build systems. So let's make a nice, convenient choice for ourselves, okay? And make our lives a little bit nicer. Okay, I want to talk to you about tables, which are the most important feature for you to understand in Lua, okay? Tables are the main data structure you will use in Lua, okay? They're kind of the only one. And each component in our engine, in our games, will be represented by a table. Each type of component will be a table, and each instance of a component will also be a table, all right, that inherit from the base table types, okay? So if you look at keyboard control and you open it up, right, this is Lua. It is our guest language, okay? C++ is the host language. And this Lua code will be running and processing atop our C++ code, all right? Whereas C++ is all about speed and deep functionality, Lua is about providing a nice time and very convenient and easy to understand APIs to our users, okay? C++ is the host language. If you look inside of our file, you'll see the name of a table, okay? A table called keyboard control, okay, that has these key value pairs inside of them. It is a key value store, okay? And there you go, right? These properties up here at the top are things that you can override, right? In the same way that you could override properties from an actor template in previous assignments, you can now override any variable that appears within the Lua, okay? In fact, you can add variables that didn't exist if you want to. Not sure why you would. It's a weird idea, okay? But you can do it. Down here are what we call lifecycle functions. These functions, on update, on start, and later you'll implement on destroy. All of these functions allow you to run logic at a certain moment in the life cycle of a component. A life cycle, right? A component is created and born, and you want to run a function. You want to run some logic. Hook some things up, spawn yourself in, render something, whatever. And then your component lives its life, okay? Every frame of its life, you do some logic, and then at its death, on destroy, you might want to do one final piece of logic to kind of clean some things up and to tie up some loose ends, as they say, okay? The life cycle of a component. So tables are components, all right? And you can see that this actor, okay, which might be a data structure in your code base, is going to need to organize basically 5 different tables in Lua and keep track of them and call their functions at the right time and make sure the right variables get plugged into them, okay? So we've got an override here. That speed variable is going to get plugged into this table instance, and that value is going to turn into a 6 instead of being the default value of 3, okay? Here you can see that we're using a function called getComponent. We're getting the component on this actor of type transform. So this keyboard control table, this component down here, is grabbing a reference to this transform component up here, and we're going to alter the x and y in that transform component, and that's what's going to actually allow us to move, okay? So one important thing is that a lot of the things you see here, right, like input.getKey, self.actor, getComponent, all these things, like many of these things, they are not built into Lua. They will fail, okay? They will crash. You will get all sorts of errors unless your engine intervenes to do something, okay? And that's what you're going to do on homework 7. You're going to write C++ code that makes getComponent a thing by default in any Lua table you create, okay? Input.getKey, this is not built into the language. You bring it to life, okay? And it'll be really fun doing it, I think. So future lectures and the assignment specification is going to help you figure out how to do this, so don't worry too much. So what I want to do right now is I want to kind of program with you, okay? I want to program some Lua code, and you know, where better else to start than in the classic, right? Hello world. So let's go ahead. I don't care about standard in. Let's go ahead and run this, all right? And by the way, this is a super good place, onecompiler.com/Lua. Super, super nice place to just go and write some Lua and see what explodes and what happens, okay? You hear about a new feature, how can I use that? Ask GPT. GPT is extremely good at giving you examples and also explaining why a chunk of Lua does the thing that it does or why it fails, okay? So let's go and let's do some stuff. I want to create a little game, okay? A little text game, all right? So here's what I'm going to do first, okay? Let's just create game start, okay? I'm going to create an array of characters. Now, in Lua, there aren't really arrays. Arrays aren't really a thing because in Lua, it's all about the table, all right? Table for everything. If you need to do something in Lua, you probably need a table. So here's what I'm going to do. I'm going to create a variable called characters, okay? And I'm going to, remember, we don't have to provide a type here, okay? We don't have to say table characters, right? What happens if we try and do this? Syntax error. We have no idea what you're talking about, okay? So I'm going to do table characters. No, I'm going to do just characters, okay? And I'm going to set this equal to, let's do 1, 2, 3, 4, 5, okay? We've just created an array of 5 numbers. Now, let's say I want to print these out, okay? Well, how do you iterate through a table in Lua? It's really weird. It's extremely weird, actually, okay? This table, I wish I could, how can I show you what has happened? This looks like an array, right? You expect to have a simple array of 1, 2, 3, 4, 5, right? This is not what you have. What you actually have is this, okay? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, okay? What you have is a dictionary of keys. These keys, by default, will automatically be numeric, okay? Kind of pretending it's an array. But in reality, it's a dictionary, okay? And so the first number is a 1, as we can see up here. The second item is going to be a 2 up here, right? And so that's what's happening. So here's how you iterate through an array to print things. Iterate through a table. For key value in I pairs. Now everyone's like, oh no. oh no, we're off the rails now. Characters. Do end. Okay? This do right here is a way of opening a parenthesis, a bracket, okay, for an array, for a for loop, okay? And this end right here is kind of the universal end bracket for ending the scope in Lua, okay? So there and do, okay? If you have an if statement, okay, let's do condition equals true, okay? If you ever want to do an if with your control flow, it's like this. If condition, I think equals true, then end, okay? You need to use then instead of do. Do is for a loop, then is for an if statement. I wish they would have just used then in both places, maybe, or maybe use do in both places. Like, Lua is famous for having very few number of keywords, but I feel like they could have used even less, which is, that's just the kind of language Lua is. I'm going to show you some stuff later, okay? I'm going to show you some stuff on the design of Lua and some fun interview stuff from the creator of Lua. And you're going to be like, oh, okay, all right. No wonder it's such a fun, quirky language. Okay, so we've got key value pairs here. And what we're going to do first is we're going to print out the key. All right? We're going to print out the key. So let's go ahead and run this. And we get 1, 2, 3, 4, 5. If we print value, we also get 1, 2, 3, 4, 5. Because what's happening here again is that the key and the value in this case is the same. All right? Let's do this now. I want to print the key, okay, to really show us what's going on. I'm going to print the key, and then I'm going to do equals, and then I'm going to print the val. What on earth are these dots?
Those concatenate.
Yes, dot dot is the concatenation operator. Don't you dare think of using plus. Don't you dare. Okay? You use this, you're going to get blown up. You use dot dot, and you're going to like it. Okay? One of the reasons I like Lua is a bit of Stockholm syndrome. I feel like I've learned the tricks, and so I'm on the inside, you know? I'm an insider with this language. This language that is so tiny and it's so welcoming, and then you get to the doormat and you just get wrecked by all these tiny little things. Anyway, okay, there are a lot of them. Now what I'm going to do here, watch this. Watch this, because this will be very, very instructive for you, I think. I'm going to change these numbers. We're not going to have an array of numbers anymore. We're going to have characters. Mario. Okay. Peach. Luigi. Daisy. Yoshi. Okay. We now have our table, but the table is full of strings instead of numbers. But you see, it is still a dictionary at heart. And what we're going to see is the values have changed, but the keys have not. Okay? So that's kind of the key to understanding what a table is. It is a key value store. It is a dictionary. However, it puts on an array costume for you, okay? If it can. So there's another way to iterate through this stuff, because I'm about to do something completely crazy, okay? Let's do another thing, okay? I'm going to print, characters finished, okay? I'm going to come up with another table. This one's going to be crazier. Stuff in my drawer, okay? And let's see, what could be there? Let's go, there's a coin in my drawer. There's also the number 2. There's also nothing. By the way, it's not null. How dare you think it's null? It's nil. We're just getting started with Lua, okay? And now what I'm going to do is I'm going to iterate through this table in the same fashion, okay? So I've got a coin, a 2, a nil, and actually I think it stopped. Oh, wait a second. Blah. Is it going to render that for us? No, it won't. Actually, a nil stops the table. That's interesting. I didn't know that. Ew. Okay, so you see how as we add stuff in, by default, it's just going to get that 1, 2, 3. It's acting like an array. But here's the thing. We don't have to make an array. We can make a table. We can make a key value store, a dictionary like in JavaScript. So here's something I'm going to do right now. Shiny thing equals coin. What else can we put in here? Oh no. I don't know what's going to happen. We can do it. I don't know what's going to happen though. You can put tables within tables. Okay. Let's go. Okay. What happens when we run iPairs? We're going to get nothing. Okay. And the problem here is that we have created our own keys, right? We've put the equal sign in here. Up here, we just have an array. We're just giving it the values, and Lua will automatically give us a key. 1 for the first one, 2, 3, 4, 5, right? But here, we've created a dictionary. And so iPairs, or like index pairs or integer pairs you can think of, now needs to just become pairs, okay? And now we explode. 14, okay? Attempt to concatenate a table value, okay? Yeah, you can't do that. All right, you can't concatenate a table value to a string. So what we're going to do instead is just get rid of it, and we'll run that. So now it can print that, okay? I don't know if this order is guaranteed, by the way, whether it will always print this item first or this one second, right? But we've got some stuff going on, okay? So there we go. And by the way, I'm going to go ahead and create some comments here with dash dash, because don't you dare use slash slash or pound, or actually I think you can. No, you can't use that one. Sorry. Okay, so let's go pairs example, and let's go iPairs example. Okay. Okay. So what you're probably wondering is, hey, I really want to create a class. Well, sorry, but Lua don't have classes, okay? It does not have any classes because it doesn't need classes, because who could need classes when you've got the table, okay? The table. All right, so let's go ahead and write ourselves a little game here, okay? What I want to do is I want to create an enemy class. But there are no classes in Lua, so instead I'll make an enemy table, okay? I'm going to call it enemy, and I'm going to make this into a table, just like this. Does this look familiar to anyone else when you see this right here? It's almost as if, hold on. It's almost as if we're kind of writing a component, okay? So where'd our stuff go? There it is, enemy. All right. Now you might say, what variables does an enemy have? Remember, this is just a dictionary we're writing, so we're going to write these variables in as key value pairs. So I want an HP variable, and it's going to start as the value 10. Okay. I want an attack variable. It's going to be 1. I want defense. It's going to be 1. I want an actor name variable. Let's call this enemy name. And the name by default is going to be question mark because we don't know what enemy this is. It could be anything. Okay. Now I want some functions. Okay. I want some cool functions that are going to do interesting things. All right. So I want a function. Let's say a function called take damage or deal damage. Okay. Let's do that. Deal damage. Okay. Equals function. Remember, it's just key value store. Okay. And then in order to conclude the function's block, its scope block, we have to write end. Okay? End terminates every scope, basically. Okay? Now, one question is, how much damage should we send in? We need a parameter. Okay? We need a parameter. So maybe, let's call it amount. All right? But actually, this is not going to work. Because if I write HP right here, I go HP equals HP minus amount. By the way, there is no minus equals in Lua. There's no plus equals. Sorry. So sorry, okay? If I write this, HP is considered to be a global variable, not this HP. Why would you think it was referring to this HP? No, this will create, I think this is actually going to fail because this is going to be nil and this is going to be nil, okay? So in order to refer to this HP, we have to go self dot. And you have to pass self in to the function, okay? So this function actually does what we want, okay? Before it was all messed up. So you're probably going to forget about that, all right? But you write enough. If you write enough Lua and play around with it enough, you'll memorize it. You'll know it for the exam. I have not written Lua in a year, okay? I did like 10 minutes of prep, and I'm still able to kind of write this stuff, and it's still kind of working. Let's make it sure it still works, actually. Okay, so there we go. Don't forget to put a comma after end. Otherwise, guess what's going to happen to us next? Okay, I want a function for printing the state of my character, and then I'll answer your question. Okay, let's go print state. Okay, equals function. Okay, and there we go, and end. Okay, and let's go ahead and print blah blah blah. Let's go enemy, and then let's go the name enemy self dot enemy name. Okay, and then we'll concatenate this in. Okay, and then we'll print HP. Okay, and then do self.hp. Okay, print HP or defense. Okay, and then self.def, and then print. Okay, attack. Okay, and then self.attack. Okay, I think that's all of them. Yeah. Okay. When I try and run this, it's going to explode. Why? It's trying to tell us here on line 28, we've begun a new function before we ended the previous key value pair. So you have to put a comma in. What did I tell you about JSON and exploding? Because you like have an extra or a missing comma. And here we are with Lua exploding because you have an extra or missing comma. So it really is JSON, the language. Anyway, what was your question, Evan?
You forgot a self. HP.
Oh, yeah, you're right. I forgot it, right? Yeah, I did. Thank you. Good job. Okay, so this is all great. And what I'd like to do is I'd like to go ahead and, nope. What I'd like to do is I'd like to create an enemy, okay? I'm going to create an enemy right here. Let's call this Goomba equals enemy. I think that's actually it. Actually, no. This is going to mess up big time. Yeah. So what happened was I didn't create a new instance of this enemy table. I just said that Goomba now refers to enemy. So I've not created a new instance, and we're in big trouble. So we need a constructor. Here's the most confusing thing about Lua in my experience. What I'm about to write is going to confuse you pretty badly. Okay? We need to write a constructor. And in general, if you create a table like this that defines a type, you can't just go, oh yeah, like Goomba equals new enemy. No, that's not going to work, okay? That's not a thing. So here's what we actually have to do, okay? We have to write a function. I'm going to call this create. You could also call it construct if you want to, but this is going to create a new instance of an enemy. It's kind of like a factory design pattern, a factory function, if you're used to that. But let's do it. Create is a function. It does not take self, okay? This is not an instance function. This is a class function, okay? So it doesn't need self, okay? Let's go ahead and write end and put the comma in. I'm going to create a new local variable, okay? Let's call this new instance. This is going to be our new enemy. But for now, in this line, it's literally just a local table. It's just a new table. Nothing special about it, okay? Now, here's where the magic happens. Here's where we establish inheritance, okay? I'm going to go set meta table. I'm going to set a meta table on the new instance, and this is the meta table I'm going to set. Currently is empty, but I'm going to give it the super special property called index, and it's going to say enemy, okay? What on earth just happened here? What on earth is this nasty line? If you understand this line, then you're golden. You don't have to worry about the rest of Lewis stuff, okay? You're done for this semester. You're good. I'm then going to return this new instance, okay? Because it is now a genuine enemy table, okay? And there we go. Let me make sure this works before I go explaining it all. Let's pass in some parameters. Let's call this new HP. Let's call this new enemy name, new HP, new attack, and new defense, okay? These four things are the parameters you need to create a new enemy. And now, after establishing in this line that our new instance is now a enemy, I'm going to do this. New instance dot name equals new enemy name. Okay? New instance dot HP equals new HP. Okay? New instance dot attack equals new attack. And new instance dot defense equals new defense. Okay? We call this function, it is a class function. We can call it without any reference to an instance. We pass in all these variables because we want to create a new enemy with these values. First, we create a new table that's just empty. It's just a vanilla table. There's nothing special about this barren table. This line is where all the magic happens, and it's hard to understand. In Lua, there is not such a thing as inheritance. There's not such a thing as classes. But we can fake this by using a special property called index. Every table that exists in Lua is allowed to be associated with a meta table. What is a meta table? It's just a table, okay? A meta table is a table that can hold these special values that change the way that Lua treats a table. So on this line of code, the new instance is just a bare, boring, ordinary table. On this line of code, we are giving this instance a meta table. That meta table is just a table that has this special property index. Index equals enemy, by the way, 2 underscores. This line right here is saying, if you ever go to get something or edit something on this table and you don't find it, it doesn't exist, go get it from this table and make a copy of it, okay? So basically, we've set up a fake kind of form of inheritance. We'll get most of the properties of inheritance, and this will work okay. Here, down here is where we basically just plug all of the incoming data into these values, and we return that new table. It's now all filled out. This table, notice, this new table does not have any functions on it. This table has no functions on it at all. It has 4 pieces of data on it, but it has no functions. So when I go and call, hey, Goomba, I'm going to call deal damage, okay? It doesn't have that function, but it's going to use its index on the meta table to go find it in the enemy table where it does exist, okay? And that's the magic, all right? Anyway, let's do this. Goomba equals enemy dot create. Is that a capital C? Yeah, create. I need to send in stuff. So I'm going to call this Goomba, okay? And Goomba has not that much health. Just kind of 10 is fine. 1. It's like the default enemy, really. Okay? But I'm also going to make a Koopa, okay? Koopa equals enemy.create. And Koopa is going to be way stronger. I'll give it a different name. I'll give it 100 health. I'll give it 10 damage and 10 attack, okay? Yep. So what I'm going to do here is now I'm going to go to Goomba and I'm going to call that print. Actually, I'm going to call damage on it. Okay, let's deal some damage. All right, deal damage. How much damage? Just 1 damage. Okay, it should go down to like 9. Then after dealing damage to the Goomba, I'm going to call Goomba. Okay, print state, and then I'm going to call Koopa print state. Okay, and let's see if I didn't blow everything up. And would you look at that? It works perfectly. Okay, the Goomba prints and all of its stats are there, and its health has gone down. We print the Koopa, and it has all of its health and its differing stats. Okay, and so we have created kind of a class instance system with inheritance. It's all kind of faked, but it's working in Lua to the extent that we need it to. Okay. And so we've got it kind of rolling here, all right? Now, a question for you. Now, look very closely, okay? I'll zoom way in. Oh, goodness. Oh, it zoomed into the wrong part. Okay, look here. I called the create function up here by going enemy dot create. So just 1 dot, right? But down here, I'm calling the deal damage and print state functions via colon. Dot to call something versus colon to call something. What is the difference? Anyone know? Yeah.
Colon passes itself.
Bingo. Colon will pass in self automatically for us. It's syntactic sugar, okay? Because colon is equivalent to this. Okay? If you do dot, the self reference is not going to be sent in automatically, and you need to send it in yourself. If I want to call deal damage, well, deal damage requires self and amount. So if I call it via the dot, I'm not sending in self, and this is going to explode, and it does on line 37. When I go in self to deal damage, self is nil, so it doesn't work. Actually, I think self is 1. Yeah, self is 1. You're attempting to use 1, okay? 1 dot HP. 1 dot HP means nothing, okay? So I have to send in self to fix that up. And it's still broken. Why is it broken?
Should we be sending in Koopa?
Oh, yeah, you're right. You're right. Self doesn't mean anything here. Like, I'm not inside of a table. So I have to send in Goomba, okay? What happens if I send in Koopa? Goomba.deal damage Koopa. Well, okay, I don't even want to think about that.
I think it would work, actually, because doesn't Koopa
Yeah, I think it would work.
Yeah,
you're right.
Koopa also has an
Oh my
HP,
God.
So you would just edit the Koopa's HP down.
Oh! I'm gonna put
that's
this.
actually cursed.
Yeah, this cursed.
What?
I'm gonna put that code on the exam. Is this gonna work?
It doesn't just have to.
No.
Yeah, I guess the whole concept here is that you can do enemy dodge deal damage.
Oh my gosh.
But one-
Yeah, this is awful. I'm gonna actually scoop this new quiz question right here. Okay, hold on.
If you hey, if you weren't at lecture today, this is your punishment.
Yep.
This is my punishment.
Okay, hold on. Where do I put this? I'm going to show you something crazy, okay? Did you know that there's a secret staff version of the schedule that has everything filled in? So I'm going to bring this up on Wednesday. Here we go.
Member? I member.
You remember? And that's actually really, I think that's a pretty good joke because like this kind of is like member function versus class function, except that doesn't really matter.
Except apparently
Okay.
all functions are class functions.
Yeah, so this is really nasty, but it still works, right? So the way I remember this is that you see how there are 2 dots here instead of 1? Well, the extra dot is the self-reference being fed in. Okay, that's how I remember it. 1 dot versus 2. 2 dots, that extra dot is the self-reference that's automatically getting put in, and it's a great time, okay? Okay, if you do mess this up on the exam, you're losing like 1 point out of 10, okay? So don't worry about it too much. All right, okay, so we run it, it works, great time, it looks good. Okay, the last thing I want to show you here is I want to show you how nice and easy it is to actually run code in your project, okay? This is the entire finished Homework 7 solution. So you can use all the code I'm showing you, okay? You're welcome. So what I'm going to do here, is I'm going to run some Lua code in my C++. Now, I've already brought down the Lua stuff, the Lua headers, so you can get all of that information on the assignment spec. It'll tell you how to integrate it. It's not too hard. What I'm going to do is I'm going to include lua.hpp, okay? If you include lua.h, you are dead, okay? And lua.h is going to show up first. It's going to show up first in the code completion. But if you stop there, you're dead. I'm going to upgrade the autograder literally in like, well, after my office hours are done, to yell at you if it detects you doing this, okay? Now, you won't be able to build, so I'm not sure how you're going to get it submitted to the autograder, okay? But this is just something you have to remember. And if you're having a bunch of crazy compilation issues, like it's almost certainly the problem. So let's do this. I want to do Lua state, okay? Lua state is where all the magic is. I'm going to call this Lua state with a lowercase s. Okay, I'm going to do, let's do Lua, I think, new state? Yeah, there we go, Lua new state. And there we go. We now have a Lua state pointer coming out and being stored in this. I'm going to do Lua L open libs, okay? And I'm going to pass my state in. This basically gives my Lua code access to things like print. The print function won't work. The math table won't work. A bunch of the minimalistic standard library that Lua does have won't work unless you do this function, okay? The last thing I'm going to do is, let's call this Lua do string, okay? And I'm going to pass in the Lua state that I want to do, so Lua state, okay? This is the Lua machine, you can think it of, the Lua interpreter I'm feeding this to. And then I need to send in some Lua code. So how about print hello from Lua? Okay, and I'm going to run this code as our engine is starting, and we're going to see what it shows. It's a pretty good feeling. I think we can actually do a little bit more than that. Can we go my message equals variables work 2. Okay, and then I'm going to print my message. Come on. See you later. Okay, so let's print it and see what happens. Will this work? I hope so. I don't think so, but maybe. Variables work too. Sick. Okay. And so you can kind of see the power we've got here. Super easy to integrate, right? You're actually going to use not just the Lua raw headers, but you're also going to use something called Lua Bridge which mainly makes it easy for you to kind of bring variables and classes and instances, right? You can bring C++ stuff to Lua, and you can bring Lua stuff to C++ to allow the languages to easily talk to each other, okay? But in any case, right, I think you're really going to enjoy this assignment, okay? Again, I keep saying it's my favorite. Maybe it won't live up to your expectations, but I really like it, and it's not changing. And I hope this lecture helps you kind of understand why, okay? It's pretty fun stuff. So anyway, that's our lecture for the day. Thank you for joining us, and I'll be around for 2 hours, help you finish up homework 6, help you get started with homework 7, or you can just go chill, okay? I don't care. I'll just be here for 2 hours, okay? Autograders will get a tiny upgrade tonight, okay? Probably around 8:30. Any questions or comments on anything? Okay, everyone, I'll put the music on, and I'll see you. Okay, everyone online, I will see you later, okay? Take care. Bye-bye.